So, welcome everyone to this session. Let me just present my screen window. Yeah. All right. So, welcome everyone to this session. I'm pretty much excited to be here. Um, so, from time to time, I will be keeping my eye on the chat just to make sure like everything is in sync and that you guys can follow me fully. Yeah. So this session basically, we would be looking at uh, what we call trusted FL at edge scale. And then just a brief introduction into myself. My name is Paul. Let me just come here so that I can see. One last time, can you confirm you guys can hear me at least? Just one last time. Okay, perfect. All right. So just a brief introduction into myself. My name is Paul. I'm an AI research engineer at the University of Aberdeen, and then I'm also the co-founder of My AI. So My AI basically is it's how do I put it? Okay, so My AI basically is pretty more or less like an AI startup that is basically focused on optimizing rewards for intelligence-driven commerce. Right. So there's a lot to talk about on that, but hopefully we would have some other session to catch up and maybe discuss more. But for this call today, I mean, what I'll be presenting is what we call trusted FL at edge scale. And I'm pretty much excited about this. And for me, I know the time is going to be really very short to go in depth into most of the things. So my goal would just be to at least sell you guys the idea of what this is all about, because I feel it's pretty much interesting. So it's just to sell you guys the idea, and then we have a little Q&A session. But I'm very much aware that we might not be able to go in depth as much as possible. So yeah, now I would need your full attention from here going forward. So let's pay attention, and then if you have questions, feel free to drop them in the chat, and then we will look at them. But I will try to be really brief so that we have more time for questions. So what you are, about to listen to is a very deep research. Made by two persons, not just me alone. So my co-researcher is Pius Onobayedo, PhD, currently doing his research at the University of Southern California. And basically, we are two crazy guys that believe in this concept of what we call collective or collaborative intelligence. So I'm very sure almost everyone on this session, we are all familiar with AI, and we already know, I mean, what AI is and the impact that AI really is having on the world today, right? Now, there are some of us that believe that even though the kind of AI we have today is very beautiful, it is still not there where we want it to be, right? Especially based on the fact that there are a few set of people controlling the AI systems we now have. So, and this is really why some of us are beginning to look into this idea of what we call collaborative intelligence. And the idea of collaborative intelligence is just the fact that rather than have one giant AI system that is able to do every single thing, why not let have smaller AI systems that can reason independently and somehow collaborate to be able to do things or to be able to learn and achieve the goal? And there's a lot of reasons to this. And then hopefully in the Q&A session, we would also be able to explore this. But this paper is trying to solve a subset of this whole idea of collaborative intelligence. Now, just to give you guys a quick background to
Sorry for the interruption. Please, could you
zoom in on my slide.
yes, please.
Yeah, but I will need to switch back and forth between the zoomed in mode. Let me zoom in for now, but I will need to switch back and forth at some point.
Okay,
Um,
that's fine. Yeah. All right.
yeah.
Thank you.
Okay, so just to give you guys, to this whole idea of trusted FL that we are working on again, just to recap, we the main focus is something we call collaborative intelligence. So just there are some keywords I will need you guys to pick as we go. I know it's not a smooth start, but just trust me as we go. I want you to pick up a few things. So what I've established is something we call collaborative intelligence, where we have AI systems that are not just one big AI like ChatGPT or Anthropic, I don't know, Grok, the ones you guys have been using, but smaller intelligence systems that could work together to achieve the same goal as these big systems, right? So now, what is the background behind this problem? Why do some of us think collaborative intelligence is the way forward? Um, there are two approaches to this, and obviously, it might be difficult to sell it to you guys from a more philosophical perspective. But just in general, let's even look at what we have observed in the real world. In the real world, most technological suits that we have basically have followed the same pattern, right? A practical example is the internet we now use today. So, I mean, a few decades ago, basically, this internet we now use today was heavily read only for people like you and me, right? So, typically, you have like giant companies like, say, I don't know, a Yahoo or an AOL, American Online, and then a lot of all these guys, they just put content out there on the internet, and everybody just simply consumes this content. All you have to do is to use and check out what they've provided you, just like the newspaper you have today, where someone publishes something on the newspaper and you read, right? I'm sure a lot of us are familiar with this analogy. But now that has quickly evolved to what we now have today, where everyone can basically contribute and give feedback. And I mean, everyone is basically a producer of content on the internet we now have today, right? You can make a Twitter post. I mean, I can speak on this conference today because the internet really has made this possible. And basically, some of us believe is the same thing we are seeing with AI. So AI, as you see today, I mean, is the same pattern where at the beginning you always have those big guys like OpenAI, like um, Google, Anthropic. I mean, providing everybody with this sort of service. They have this giant model in some data center, and then they provide everybody. All we could just do is engage with ChatGPT. But some of us believe an era will come where it would be the same thing with the internet, where rather than just always using ChatGPT, we can contribute to train this sort of system that we would have in the future, right? Where you and me, the same way on the internet, I can add my own content, I can post my own videos, I can come to speak. It would be like that, where we all can collaboratively train the AI systems that we have today. So that is the I mean, if you want a rough background, but more than just looking at patterns, why does it really matter? Like, why is it important to think of an AI system where, I mean, the we have smaller pieces of intelligence rather than some very large piece, right? There are many ways to look at it, but I think the easiest one to do is to start from practical challenges that we've already observed, right? So there are a lot of issues we already have with current systems. I don't know if you guys are familiar with this, but I'll try to rush through this ones very quickly. One typical case is the Cambridge Analytical case. If you guys are familiar with this one, so this one is a very special one where Facebook somehow harvested a lot of data from people, and they used this data for political manipulation, right? It was a very big case, and of course, it falls back to the same idea of you have some giant entity providing a service to so many people. What happens is this giant entity controls so many things that are really going on under the hood. You don't get to know what they are doing with this data. I mean, but they do a lot of manipulation, and Cambridge Analytica was an example. The one they really used for political manipulation, right? You guys can, I mean, check it out in details. It's a very, very interesting one, and it really goes far to show that at even at we can at least agree, maybe for cloud we can agree to use AWS, but for things as integrated as intelligence, I mean, it's really, really tricky relying on some central guy to just provide you the service, because they can do so much manipulations, right? I mean, the Cambridge Analytica one is not so interesting. The ChatGPT data breach of 2023 was even a more severe one, where this is even more severe. I know a lot of us use ChatGPT today. I use ChatGPT a lot, right? And 2023 showed us like how really dangerous it is. And for me, for example, I've really streamlined sort of communications I have. So in 2023, many things happened. All conversations of people with ChatGPT, most of them were leaked, people who had put payment information and everything, well, they were leaked, and there was a massive sort of attack globally, right? And some people are still complaining about losing some money based on this. I mean, it's a very long story, but long point short was that even today, as we all use ChatGPT, I think Sam Altman also came out and said that, in fact, your chat history with them can be used against you in the court of law, right? So, which is quite interesting. We all are relying on this intelligence system the same way we've been used to working with Google search and all of that. But now we are getting to find out that if these providers who provide us these systems get hacked or they have some bug, I mean, obviously all your conversations on chat history would be exposed. I don't know what you tell ChatGPT, but you just get to know that it's not safe, right? So there are many other issues. The first one is the governance issue. So this governance issue basically speaks to intention, right? I mean, it is easy to basically assume that, oh, well, ChatGPT, they're a good guy. They are good guys. They are regulated. Their privacy policies and all of that. We will be fine. But again, saying that would mean you are trusting the governance of OpenAI, right? That maybe they are good people there. But governance can always change. Even if you have a very good setup today, the current setup can be fired. Maybe there's some US policy or some government policy or just internal crisis. And we saw that happening also in 2023, where, I mean, the CEO was going to be fired and a lot of employees wanted to quit. And so many things basically leaked based off those. And so for me, surprisingly, I don't even know how OpenAI managed to get through all of this and still remain standing. Another example I could give you, and I could go on all day, is algorithmic bias. Now, I mean, if you guys are not aware, most of the decisions being made today on a financial scale are really AI driven, right? I mean, I do some things in the financial sector very, very well. I mean, one of the lead blockchain engineers for one of the biggest layer one blockchain today, maybe in the world for interbank settlement, right? So one of the things, I mean, really in the financial sector are really decided by AI. Should we give this guy a loan or not? And even down to jobs, sometimes should we hire this guy or not? And a lot of times the question is, who are those training these models that are being used to make these decisions, right? Imagine it's some guy in Silicon Valley. Maybe he trains this model with quote unquote the data of a lot of American people and then profiles these people are the best fit for this kind of jobs. And therefore you see a lot of people, maybe someone from, I don't know, Asia applying for jobs and getting rejected simply because the AI that makes the decision is biased towards the training of the platform provider, right? So algorithmic bias, and I mean, this happens, and we can't deny this because the people who provide us these centralized services, they must train the models on some data, and most likely they will work with the data they have the most. Maybe they try to go to other regions to sample, but they work with what they have the most. And don't forget, it's not just about geography; it's about everything, biology, every aspect of life. There is always a bias if there's one person that is providing the AI the base to define what is true or not. So I can keep going on and on, but I think I will really just stop here so that, I mean, but again, like I said, my goal is to sell you guys the idea. I know we can't go over all the deep cryptographic stuff now, but it's just to comfortably sell you guys the idea so that you guys can see where we are coming from with this. Now, again, I don't know if you guys can see this board. I just pull up this board just to throw more ideas around this, and then we go quickly into the other part. Can you give me a thumbs up if you can see the board? Sorry. Okay, perfect. All right, God bless you. So now, philosophically, it even doesn't make any sense to think of an AI system, one giant system servicing the world. And that's why this model apparently is going to fail when we get to this economics of scale we want to get to. For example, imagine Tesla successfully launches their self-driving cars, the Tesla car, and to be able to make the decision, this car needs to call some API to Tesla's data center while you are on the road. I mean, that's not going to scale, obviously. The car itself needs to be intelligence. The intelligence needs to be on the car. It shouldn't be making a call to some external large trained model somewhere, right? And the problem with having self-intelligence is that there are two challenges. Imagine I have your car, or let's say your phone, or anything. Remember, we are proposing this idea of edge intelligence, right? Where we have smaller things that are intelligent and they are working together. If I have an intelligent car, for example, there's a model in the car, is smart, it knows how to drive itself. If this car doesn't learn from other cars around it, for example, it's going to be self-absorbing, meaning it only knows what is happening based on itself. And that's also not good because that doesn't, it leads to a lot of other problems, which I don't know if we would have time to go into. But this whole idea wouldn't even work. So even if Tesla was to create some model and put it on a car and maybe put the whole data center inside the car itself, it will still not scale because this car still needs to be able to engage with other cars intelligently. And from a more philosophical perspective, it's just really how the world really works, right? Maybe I'm not so smart. I'm trying to be smart. A lot of you guys on this call, yeah, very smart, different levels of smart.
Hi, Paul. Can you please present instead?
Can you hear me?
Yes, we can. We can hear you, Paul. Can
Yeah,
you please
yes. Present this. Yeah.
yeah,
So I have
click
some
on
of the content on this board. I don't know if because on the slide they are not there. I just want to touch on those points. I don't know if that's okay.
Yeah, that's fine. There's a present button on that page too, just so we have like a better view.
Better view, present. Okay, this one. Okay.
Yeah,
Okay,
thank you.
perfect. Yeah. So, okay, so yes, I mean, there's a lot of things. Then there's something we call attribution, which again I would like to go over with you, but might take a lot of time. But the main idea is just that for a lot of us, we think about AI differently. The way the world is providing AI today is to say, look, let's build this giant super intelligent system that's gonna serve everybody, right? But the way we are thinking about it is look, let's build intelligent systems that can cooperate with other intelligent systems. And when they need to learn based on their interaction with other intelligent system, rather than trying to just focus all our training on one system that serves everybody. Let's have independent systems that can collaborate and learn. And this is the basis of our project. So now, okay, so let me see. So this whole intelligence system we are talking about basically that we've introduced in this call, is it new? Is it a new concept? I mean, are we the ones creating this concept? Obviously not. There's something we call federated learning that already exists today, and this is already so big. I mean, a lot of great work has already gone into this. So federated learning today, and it already works, right? So for example, one of the key play of federated learning is your autocomplete on your phones. So I mean, a lot of us we use WhatsApp, we use Twitter, Instagram, and all of these apps. Sometimes when you're typing, even when you want to send an email, for example, when you're typing, you will automatically see that something is suggesting the next possible word that you should be typing to you, right? That is what we call autocomplete. Like as I'm typing, I'm seeing the next set of words that maybe I would be interested in selecting, right? This is what we call autocomplete. Of course, initially people were doing autocomplete the same way this whole ChatGPT stuff works, whereby they were trying to use API to send your text to some external server, some large model like ChatGPT, and then predict for you the next word. Of course, that was so bad. Even though we didn't complain, but obviously that was bad because it means every message you are typing on WhatsApp, as that stuff is predicting for you, is actually collecting your data. So let's say you were sending your password to a friend, or you were sending your card details, or you were even chatting with your loved one. All of those things are being leaked. So we knew we needed to solve this problem, and then many iterations came, but finally we landed on something called federated learning, where rather than sending the direct message, we do something that we call sending of the model weights. So now I'm beginning to go more technical, and I don't really know where you guys are gonna lose me, but I mean, just believe some of the things I'm saying, and hopefully they will become clearer with time. For me, the goal is for you to pick the very key things, and then just learn the concepts, and maybe after the session, go and learn more about them, and then I mean, yes, just begin to widen your train of thoughts around these AI models. So every AI model basically has something we call weight, right? If you were to ask me what's an AI system, I would tell you is basically like a database. It's nothing more than a database. But this database, instead of storing rows and columns of username and email and password, it stores all these things. It converts them into what we call vector. Yeah, I don't know if we did vector in school, but vector is like all this array or matrix where we have 1 and 0 and 0.5 and all of that. So it converts this whole thing into a vector, and that vector is basically what it stores. And so when you ask the AI a question, What it does is, again, it does many things, but I can just say, let's assume what it does is it converts your question into that vector format, and it tries to superimpose the vector you ask it on the vector database it has, and then returns to you things that are similar. Something like that is basically what it does. So the goal with federated learning is, rather than sending the text message, why not let's convert that text message into a vector on the person's phone when it's typing, and then send the vector instead. And so this is what federated learning is doing. So they send the vector to some central guide, the same thing we are doing with ChatGPT, where every time you type, you are calling an API to ChatGPT, basically. Even when you use the interface, that's what's happening. An API is being called to the server, it returns to you a response, right? But rather than sending the text, let's send a vector instead. And this is what we've seen, right? But there are a lot of issues with, with federated learning itself, right? We can go over many issues, but the primary issue is trust, where you are trusting some centralized person, say Google and all of that, to still really collect all of these vectors from everybody and aggregate this vector correctly and then push it back to you guys for local learning, right? So just again, a lot of complicated stuff, but the primary problem with FL we have today is still the same trust issue. Imagine we have people from all over the world typing on WhatsApp. What if WhatsApp decides to be more biased towards Nigerians and say, you know what, we want Nigerian message to be more dominant, so we only accept vectors from Nigeria, or any vector coming from, I don't know, the United States, we are going to damp it down. So all of these plays are not just, we are not just speculating, they're actually happening where people are intentionally being biased. And so these are some of the gaps that really led to our model. So federated learning basically allows us to do this thing we talked about, where smaller systems can learn on their phone or on their own, like your phone. An AI system can be trained on your phone, and then the training happens, converts to vector, but rather than sending the message, it sends the weight to some aggregator somewhere. And this is how collaborative intelligence has been. So FL is a form of that collaborative intelligence, but it has a lot of gaps. And this is where our research now comes into play. We want to solve these gaps. And now we do these gaps by 4 very boring methods, which I don't know, only God knows how we're going to talk about them, but they are so boring and so uninteresting, but they are beautiful in the sense that they really can work, right? The first method is what we call proof carrying aggregation. Now, again, proof carrying aggregation is basically a strategy where we are saying, rather than, think about it, the current problem today is that there is a company that is still providing the aggregation. So let's go back to your phones, right? I think I should invest my little 5 minutes into this concept. Let's go back to your phones, right? Again, let's say you are typing on your phone, you want to send a friend a message. You would see something that automatically suggests to you the next word. That thing is an AI system. And we've said it is bad for the AI system to know the next word by sending your message itself to the AI, right? Rather, what would be good is if we have the AI on your phone and the AI learns and does the vector, but rather than sending your raw message, it sends the vector to some other server. Now, the question will be, why does it need to send the vector to some other server? That is where the collaborative intelligence comes in, right? Because if you are typing on your phone and the AI is only training based on your typing, it can learn concepts from your friends, right? Let's say your friends are like, how you day now, for example, and you have never typed how you day now before. The day you type how you day, the AI will suggest to you now. How does it know that now? Because your friends are typing that. So it's able to collaboratively learn. And the way that happens is that across you and your friend and everybody, the AI trains your language, converts it to this vector, and sends it to someone to aggregate you and all your friend. And when this person aggregates, your phone pulls that aggregate back to itself to retrain itself on your phone. That's why your AI on your phone is able to know how you did now, even though you never typed that before, right? Now, the problem here is that this person is one person, let's say Google, and they do a lot of manipulations with this stuff. I don't want to go into all of those details. So we are now proposing a way where it's going to be almost impossible or so difficult for these guys to do this manipulation. And that's what we call this proof carrying aggregation. Now, maybe in the Q&A we can talk about this, but it's a lot of boring stuff. Now, let's see. The other thing we have here is what we call geometric novelty decomposition. And this one is really, really unique, extremely unique to us, in the sense that today, a lot of the federated system we have, they assume that people are generous, meaning people are just going to volunteer to have their device run intelligence, and that's just it. But we think otherwise. We think that if people are going to run an intelligence system, let's say you, for example, your phone, as you're typing, everybody's learning from what you're typing, right? Or it could be you have an AI robot in your house, and the way you engage with this robot in your house, first of all, we don't want this robot to be calling some central API. Otherwise, it means every conversation you have with the robot or in the presence of the robot, let's say you're speaking to your wife and your children in the presence of the robot is sending it to some server. We don't want that to happen. We want the robot to be self-intelligence on its own. But this self-intelligence, we want to learn from this your robot. And that's where this collaboration thing comes in, right? But why would you volunteer to let us learn from your robot? It doesn't really make sense if there's no compensation to do that. What if every time we learn from your robot and we successfully learn, we can reward you with something? It doesn't have to be money. It's score. It's anything it could be. And this is what the idea of rewarding is. Now, everybody runs away from rewarding in federated learning, especially in secure federated learning, because everything is encrypted. How do you know what somebody is contributing? How do you know this guy is even contributing any meaningful thing? It's so difficult to tell. Or how do you know that this guy is not just replaying someone else? Let's say I contributed something meaningful. Some hacker just grabbed what I contributed and resubmit it again. How do you know that that's a meaningful contribution? Or what if I'm just contributing gibberish? Or what if I split all my contribution into pieces and send? I mean, there's so many ways to game this stuff. So we created this mechanism called geometric novelty debugger, which is not that we created, we just applied some other concept that uses vector. I don't know if we did vector in school. We always know that every vector can be decomposed to some form of another vector, right? And this is the idea we leveraged. And I think we can really go into this, but this is so genius level work. And we are really proud to have this. Now, the other thing we did is object-centric coordination. Now, again, I know I have lowered the quality of all the things I'm talking about. Just pardon me. I just want to rush through the slides. But my goal is to sell you guys the idea, right? So for object-centric coordination, basically, again, this architecture we are proposing where there is no one single person aggregating. We have a network of possible aggregators. Even your own robot could be an aggregator, really. And what happens is that the ecosystem randomly chooses who does the aggregation of the knowledge and disposes back to everyone. That thing is similar to what we have in blockchains, right? Where you have a set of nodes and you have a committee nodes, and this node basically does the aggregation. In 1 minute, I'll be done with this, right? But blockchains have a lot of challenges, which we already know. And I mean, but there was this new blockchain that came up, which is called SUI. And this SUI was able to break some of the challenges by using something that we called owned and shared object. So which we also applied in our concept and discuss scaling of the learning, because one of the biggest challenge with doing this collaborative learning is, does it really scale? And then we've been able to conquer that with this. And then we have something we call time law governance, which basically is the way we govern the system. No collaborative system can work without some form of governance, right? And we introduced this idea to do that. And so with the governance, with the secure aggregation, with the reward systems, and with the object-centric coordination, we have been able to deal with a lot of the problems that current federated learning systems are having. Now, what are the challenges with our work? Obviously, these are all theoretical concepts. It's the same way a lot of this modern architecture started. So we are yet to put into implementation, and we hope to do so very quickly. Geometric novelty decomposition has some challenges, which is it doesn't really know the specific contribution from one person. So a lot of things we can go into. And then, yeah, this is the end of my slide. And I want to end with the fact that we believe that really AI should be collaborative. And this is where the future has to go. There is no other way it can be. Maybe there are some giant systems that some businesses use, but the common purpose AI has to be an intelligence of the people, by the people, and for the people. And all this work we are doing is not maybe to solve everything. We just have to pass the baton off to someone else that would do some of the other things. So yeah, this is it. Sorry, I took a lot of time, but yeah, thanks a lot.
Thank you very much. Thank you very much, Paul. We have some questions from
Okay. Let's run through this.
Yeah. So I'm just going to read them and then you'd take a few of them.
Yes.
Yeah. So Okpayemi says, your goal was to sell this idea to us. Are there any practical steps you'd encourage us to take?
Well, again, I think the practical step is to just start maybe reading about federated learning as much as possible, because these are very new stuff. They are not like, and even we have not built them. Theoretically, they work, but they are very new stuff. So I think just start learning about federated learning. Maybe read our paper, and then that will be the beginning. But most important thing is to rethink how you see AI, rather than being satisfied with using ChatGPT. Think about it like, what if it could just be instead of collaborative intelligence systems? And it's not even what if, it has to be, because no other situation would work. Okay. I don't know if I answered that.
Okay, so I'm going to read the next question.
Yeah.
Abib says, we see new models almost every week. Is the assumption from this approach that everybody convenes on one model architecture, given that model weight structure differ by models?
Given that what, sorry?
Model weight structure differ by models.
Yeah, but we are not looking at models. Don't forget, we don't care whatever models are running, but we are saying this model should not be in isolation. I can't have my model isolated from your model and the other person's model. All these models should be able to collaborate. First of all, they should be local. They shouldn't be managed by one giant company. They should be local. All of us can have our own instance of these models, but these models should update their knowledge by collaborating with other models. That's what we are saying. Yeah. Okay.
Yeah. Just to add to that, to extend this question, I think what Abib is really trying to say is the structure of model weights could differ depending on the kind of model.
Yes. So the interesting thing is about one of the sort of aggregation we do now for this particular problem. Again, we are targeting a particular knowledge. So let's say autocomplete. All models have to be, the models that are collaborating are solving similar problems. For example, a car is not trying to collaborate with a toaster, a smart toaster yet. A car is trying to collaborate with a car, and we believe that this service would have these cars having similar learnings, similar weights, at least for now, right? Where they have similar learnings, they have similar type of models running in each all of them, and then they are collaborating based off those. But I think it would be interesting to see asymmetric models, how they could collaborate also. I think that would be interesting. Yeah.
Okay, so
I don't know if I touched the question, right? I'm just saying it's focused on the same task. So let's assume same task, have same weight, and they are all collaborating based on that task. Yeah.
Yeah. Thank you, Paul, for your response. So this will be the final question we'll take because we have just 1 minute left. So Moete says, even if AI training and inference is distributed, what would prevent the landscape from becoming like the current blockchain landscape, where there are people who control a large part of the pool due to having so much computing power? I think the corporations will still contribute most data in the end, and regular people wouldn't be able to influence the system much.
No, that's not true, because regular people are far more than. So the thing with blockchain is heavily a financial system. I work in blockchain. I'm a blockchain engineer first. It's heavily a financial system where there is financial reward and very complicated stuff. AI is different. AI is everybody's doing it. I mean, how many people in the world even use blockchain? Not a lot of people. But AI, so many people use AI. So the mass populace is, I mean, think of an intelligent car using this learning to collaborate. Doesn't matter how many big cars billionaires try to buy, people have more cars than them. When you aggregate across people. So this solves day-to-day problem. It's not just a concept for a niche people like Web3, where if you have money, do crypto, or a few people are, maybe 10% of the world, or even less than that, is doing crypto blockchain right now. But larger percent is doing AI. So this is more general purpose. And then, so they can't, the majority people can't outshine the system if it's properly built. And if you have a large number of day-to-day independent people. Yeah. I don't know if I touched that very well.
Yeah, thank you very much, Paul, for your insightful talk. I hope this pushes every one of us here to look more into federated learning and how we could improve the existing structure of things. Thank you, everyone, for attending this session.
Thank you, guys. God
let's
bless
take a
you.
look at the schedule for the next set of sessions. Thank you very much.
All right. God bless you, guys. I really appreciate you for the session. Hope for the best.